This is 2.4, the product rule. So this is the same product rule that we covered when we were doing Unit 1. But in Unit 1, we were only using function notation. In this section, we will define our functions using function equations. But just as a refresher, to do the product rule, we use the box. We took the first factor of the function and the second factor of the function, so in this case f of x and g of x, and put them in the top row of the box. And then we took the derivative of each of those and put them in the bottom row of the box. Then we started in the lower left-hand corner and multiplied the diagonal, and that diagonal got us this first term. Then we added a plus sign, we multiplied the other diagonal, and that diagonal got us the second term of our formula. Now when we do the product rule, we have to identify our two functions. So what you want to find is you want to find two things with x that are being multiplied together. So in this function, I'm looking for where the multiplication is. When I look for the multiplication, I see that x squared is multiplied by the parentheses. So I'm going to split my function up that way. So I'm going to go ahead and set up my box. I'm going to put x squared in the upper left, x squared plus 3 in the upper right. So let me go ahead and highlight those so that we recognize that those are from the original function. Then I'm going to take the derivative of both of those. So now I use the new derivative rules that we've learned in this unit. So x squared, I'm going to bring the 2 down in front, reduce my exponent by 1, so I get 2x. And then 2x plus 3. Well, the derivative of x squared is 2x. The derivative of 3 is 0. So I can put the plus 0. I don't have to. Then I'm going to go ahead and do my diagonal. So I'm going to do yellow diagonal and get that y prime equals 2x times x squared plus 3. Plus, then I'm going to do green diagonal. And that's going to get me x squared times 2x. And then I'm going to clean this up because I can take the 2x out front here and distribute it into the parentheses. There's nothing stopping me. There's no exponent on the parentheses that would stop me. So that gives me 2x cubed plus 6x. And then the second term, that's just x squared times 2x. So that's 2x cubed. I now have like terms. So I can make that 4x cubed plus 6x. And so that's an expanded form. Eventually, we're going to be going as far as factoring stuff out. So if you want to practice that, I can go ahead and take out a 2x and get 2x squared plus 3. Okay, so either one of these forms is fine, but eventually we are going to have to go all the way to that last form. Next example. So for this one, I'm going to look for my two functions. I want to find where the multiplication is. So I see x minus 5 times x squared plus 4. And so I'm going to go ahead and for my box, put the x minus 5 and the x squared plus 4 in the top row. The derivative of x minus 5, well, the derivative of x is 1. The derivative of negative 5 is 0. So that's just going to be 1 plus 0. Derivative of x squared is 2x. Derivative of 4 is 0. So I'm not going to write that one either. And I'm going to say f prime of x. And I'm going to do 1 times x squared plus 4 plus, and then I'm going to do x minus 5 times 2x. Cleaning this up, I'm going to have x squared plus 4. I'm going to distribute the 2x. So I'm going to have plus 2x squared minus 10x. Combining like terms, I do have an x squared and a 2x squared, so that's going to give me 3x squared minus 10x plus 4. I can take a quick look and see if this factors. I don't think it does. 3 times 4 is 12, and 12 I don't believe has factors that get me to 10. Next example. Some people think that it's a little easier to find your functions when you're dealing with trig, because with this one, we've got 3x and then cosine of x. Okay, it's never cosine times x. Some people tend to try and make it do that. It's just cosine of x. That's one unit, one factor. So then I'm going to do my box. I'm going to say 3x and cosine of x. Derivative of 3x is 3. Derivative of cosine of x is negative sine of x. Then I'm going to do my diagonals. So I'm going to say g prime of x. Start in the lower left and say 3 cosine of x plus 3x times negative sine of x. When there's trig involved, there's usually not much to clean up. What I could do is say 3 cosine of x and then bring that negative out, make it minus 3x sine of x. If I wanted to factor something, I could factor out that 3, make this 3, and then cosine of x minus x sine of x. Okay. And like I said, the factored form is going to be more useful to us as we get into further units. But for now, just simplify to expanded form if you prefer. Next one, I see sine of x multiplied by cosine of x. There are two x's. So I pick one thing with the x to be my blue and one to be my purple. So then I'm going to draw my box. And I'm going to say sine of x and cosine of x in the top row. Derivative of sine is cosine, so cosine of x in the bottom. And negative sine of x is the derivative of cosine of x. H prime then is going to be equal to, I'll start in the lower left-hand corner and say cosine of x times cosine of x plus upper left-hand corner sine of x times negative sine of x. So that gives me cosine times cosine. Cosine times cosine is cosine squared. So I can write that as cosine squared of x. I can bring the minus out, then I have sine times sine, which is sine squared of x. At some point in a trigonometry course, you may or may not have seen this formula. So just as a side note, this is actually equal to cosine of 2x. You don't have to know that. That's not a requirement, but it's available to you. So it's a formula. It's a trigonometric identity. Okay. Next one, we're adding a little context to the problem. So it's not just find the derivative. Now it says find the slope. So usually finding the slope indicates they're going to give you an x value, and they do. So to identify our function, I'm going to go ahead and see where the x's are and what's getting multiplied. So it's 3x squared times x squared minus 3. So I'm going to go ahead and set up my box and say 3x squared and x squared minus 3 in the top row. The derivative of 3x squared is 6x. The derivative of x squared minus 3 is 2x plus 0, which I'm not going to write. And then I'm going to go ahead and write out my y prime. So I'm going to start with the 6x. 6x times x squared minus 3 plus 3x squared times 2x. The nice thing about plugging in a 1 is you really don't have to simplify what you're working with. So I can just go straight to y prime such that x equals 1. And that straight up and down line just means this is what you're plugging in. It's an indicator when you don't have parentheses to plug into. And we're going to say 6 times 1, and then 1 squared minus 3, and multiply those together, plus 3 times 1 squared times 2 times 1. So we've got 6 times 1 minus 3 is -2, plus 3 times 2. So we've got -12 plus 6, which is -6, and that is our slope. Next example, same thing. So we're finding the slope. Slope means derivative. So we've got to take a derivative of our function. We're looking for two spots that have x's that get multiplied together. So this is 4x cubed times sine of x. So 4x cubed is going to be our first function, and sine of x is going to be our second. So to set up our box, we're going to have 4x cubed in the upper left, sine in the upper right. The derivative of 4x cubed, 4 times 3 is 12, and then reduce your exponent by 1, so x squared. Derivative of sine is cosine of x. So then we're going to say y prime equals, and we're going to start in the lower left, 12x squared sine of x plus 4x cubed cosine of x. I'm plugging in, so I can go ahead and plug in right away if I want to, and say x equals pi over 2. So I'm going to have 12 times pi over 2 squared sine of pi over 2 plus 4 pi over 2 cubed cosine of pi over 2. Taking pi over 2 and squaring it and cubing it is a little unreasonable, but we can go ahead and take the sine and the cosine of pi over 2. So I'm going to say pi over 2, or I'm going to say 12 pi over 2 squared. Sine of pi over 2 is 1, because it's the top of the unit circle. The y value is 1, plus 4 times pi over 2 cubed. Cosine of pi over 2 is 0, because that's the x value at the top of the unit circle. And so we have 12 pi over 2 squared. The second term goes away because it's multiplied by 0. If it's really bugging you, you could write this as 12 pi squared over 4 and make this 3 pi squared. Okay, but once you've evaluated the trig, you're done. You can stop. Okay. Next one, adding a little bit more context. Now we're not just finding the derivative. We're not just finding the slope. Whoops, we're finding the equation of the tangent line. There we go. So we're finding the equation of the tangent line this time. So that means we're finding a derivative. I'm looking for two things that get multiplied that have x's in them. So there they are. So I'm going to go ahead and with my box, put x minus 5 in the upper left, 3x squared minus 5x plus 1 in the upper right. The derivative of x is 1. The derivative of 5 is 0. So the derivative of x minus 5 is just going to be 1. Derivative of 3x squared is 6x. Derivative of minus 5x is minus 5. And the derivative of 1 is 0. So setting up my derivative, I'm going to say f prime of x. I'm going to do 1 times 3x squared minus 5x plus 1 plus, move it down here a little bit because I'm going to run out of room, x minus 5 times 6x minus 5. So then I'm going to find f prime of 0, because it told me to find the derivative at that point, or find the slope of the equation of the tangent line at that point. So I'm going to plug in 0. So I'm going to say 3 times 0 squared minus 5 times 0 plus 1 plus 0 minus 5 times 6 times 0 minus 5. So let's see what we have. We have 1 from the first piece, and then we have negative 5 times negative 5, which is positive 25, which equals 26. This is going to be our slope. We need 3 things to make a line. We need an x, we need a slope, and we also need a y. So I'm going to find the y value. I'm going to plug into the original function. So I'm going to find f of 0. And I'm going to do 0 minus 5, 3 times 0 squared minus 5 times 0 plus 1. That's going to give me negative 5 times 1, which is negative 5. So that's my y value. So I'm going to use point slope formula. I'm going to say y minus my y value, which is negative 5, equals my slope, which is 26, times x minus my x value. I'm okay to leave it that way. The double negative is a little strange, so we're going to make it y plus 5 equals, and if we're going this far, we may as well make it 26x. Okay. If you want to, you can subtract the 5 over, make this y equals 26x minus 5. So put it in slope intercept instead of point slope, but it's not necessary. Last one, equation of a tangent line. So for an equation of a tangent line, you need an x, a y, and a slope. I've got the x and the y. We've got pi and 0. Now I need the slope, so I need a derivative. I'm looking for my x's. I see a 2x, I see a cosine of x, and they're getting multiplied together. So I'm going to go ahead with my box, make this 2x cosine of x. Derivative of 2x is 2. Derivative of cosine is negative sine of x. So g prime of x, starting in the lower left, is going to be 2 cosine of x plus 2x times negative sine of x. I'm going to plug in my x value because I need that slope at that point. So g prime of pi is going to be 2 cosine of pi plus, actually, while I'm here, I'll make that negative 2 pi sine of pi. So I'll just bring that negative up to the beginning of the term. Cosine of pi is negative 1. So then I have 2 times negative 1 minus 2 pi sine of pi is 0. So that whole term goes away. And I'm just left with negative 2. And that's my slope. So then I'm going to have y minus my y value, which is 0, equals my slope, negative 2, times x minus my x value, which is pi. You can leave it that way. If the 0 is bugging you, you can do y equals negative 2 times x minus pi. You can even distribute the negative 2 if you want to.